In this series of videos, we're going to go through and give you a bit of an introduction to Java. Now, Java is a programming language that has been around for a long time, and Android apps primarily use Java and you'll be using this yourself when you're developing apps. Now, there are other languages that can be used for Android apps, but Java is probably the most common and is certainly the language that we'll be focusing on during this course. So this is the first video in a series of videos to teach you the basics of Java to help you as we progress further and create ever more complex apps. So let's get started. Okay, so here we are. We have installed our tools and so forth. So we're going to go into our Android Developer Tools bundle folder, double click that, into Eclipse, double click that, and double click. Now, depending how you get to this page or when what the order is that you've been watching the various sections of this course, you may have some existing apps or you may have nothing. So as you can see, I've got an existing set of apps already open. So the first thing to do would be to close any of the files that you can see here, because we won't need those. We want to start fresh. And if you see any packages over here that have got an arrow next to them, that generally means that they are still open. We want to right click and select close. So we want to start from a clean slate, and we don't want to have any other project open that might confuse us. So long as everything's closed and there's no arrows showing to the left, we know that they're all closed. Okay, first things first, we need to create a new Java project. Now, this is different to creating Android projects that you saw in the previous section when we created our first app. In this section, we're creating pure Java programs that aren't apps. And the reason we're doing that is it's a lot easier to teach Java, where we're outputting the contents to our screen here rather than trying to load up Android virtual devices and so forth. We'll be doing that later in the course when we're creating more apps. But for now, for learning the basics of Java, it's best to do it in this environment. So to do that, we come up to File, click on New, and this time we select Java Project. In the previous, our first application, we selected Android Application Project, but here we're selecting Java Project. It comes up and asks you the project name. We're going to call that very simply Learn Java. Next, we need to set up a Java runtime environment, and by default, your screen will probably look similar to this. And if this says currently unknown, you'll need to click in there, click on Configure, click on Add, Standard VM. Now, again, I'm on a Mac. You should find with Windows, it will automatically have found that for you. But on a Mac, you'll need to go into the Apple menu, System Preferences, down here to Java. Give it a second to load. Then go into Java and click on View. And that gives us a path. So I'm going to type in that, we'll select in that path and copy it. And cancel out of there now. Close that down, and we're going to paste that in there. And what we're going to do is delete the last part up until the home, like so. You can see as soon as I did that, it automatically added all this for us automatically. I didn't actually have to do anything. So the complete path will be ending with /home/. Once I've done that, it also added the JRE name for home. I'm going to leave it like that and click on Finish. We've now got a path in here where we didn't have one before. Click on OK. Then down here, use default JRE. We haven't got an unknown anymore. So if you've got something that doesn't say unknown, you know that you're in the right spot, and we've got that now. So now we can continue. And we can just click on Finish. So we've now set up a Java project, and you can see that it's got the little J there to indicate it's different to these other packages, which are Android specific packages. Okay, so I'm going to expand this now. I'm going to right click where it says SRC for source and click on New and select Package. We're going to type org.example learn. Doesn't really matter what we type there. This is purely for testing purposes, but we need to have that there. So you can see that I've got that now. Now, once we've done that, we need to right click that, select new. This time we're going to select class, and we're going to call that demo. Now we don't go down and click finish. There's one other step we need to click, which is here, public static void main. We need to click on that, and without going into too much detail, that will enable us to output results to the console window in Eclipse so that we can be testing our Java projects. And click on finish. And Eclipse will automatically create some code, as you can see here. I'm going to double click up here now to make that full screen. And we just want to walk through briefly what Eclipse has done. It's created something that's called a class. And we're going to get more into classes in a future video, so I don't want you to get too worried about that yet. But essentially, this is a definition of a class. You can see it's a public class is the sort of Java keywords to indicate that it's a class, and demo is the class name. And a class is contained within a starting squiggle, like left squiggle bracket. It's not the standard bracket. This is the standard round bracket. I call it a squiggle bracket. It's normally, it's often on the keyboard, it's to the right of your P and a shift. So a Java class is comprised of that. So this collectively, this definition there with the starting and ending brace is another word for it, is basically is a class. So what we're doing now is we're going to do a little bit of work in here, in this little method in here. This is called a method. And we're going to do something really simple. We're going to print out a message to the screen. So what I'm going to do is just move my mouse over and to the end of the, this is called a comment, by the way. This line here with the two forward slashes, what that tells Java to do is to ignore anything that comes after it. So anything after two slashes, firstly you can see that Eclipse has made it green, and green tells you that it's purely there as a representative or something to help you, and it's not going to be executed or run or processed in any way by the computer. So I'm going to go to the end of that line and press enter. I'm going to type something really simple. I'm going to put system dot out, and you can see as I'm typing, Eclipse is helpfully giving us some options. So I pressed the dot button. It said, oh, okay, now which one do you mean? Now we're looking for something called print. You can see there's a few different options for print. There's print and there's print ln. So we actually want the print ln, which will print whatever message we put in brackets, which I'm going to show you how to do shortly. And then it's going to automatically move on to the next line. Because if we didn't add that ln to the end, we would have our output going from left to right and never never coming down on the screen, so you'd soon not be able to read it. So I'm going to select print ln, so I've clicked on that once, and it's going to press enter. And you can see how it's filled out by Eclipse. And now I'm going to type in, this is my test message. Okay, very simple. And anytime you're typing, if you see something funny, like a red cross, that will tell you that there's a problem. So to get a Java program working, and this applies for Android apps as well, and we'll talk about this further in future videos, anything that's red like that is an error that has to be fixed. So it's saying here, if you take your time to read it, it's normally pretty good. It actually said ASD cannot be resolved to a variable. You saw that on the screen just before I moved. So I'm going to delete that. And that should take it away automatically. So now I'm going to double click on demo.java, and we're ready to do an example run to see whether we can get Java to do something. So we're going to, I've selected Java, I'm going to right click it, click on run as. You notice it's automatically saying this is a Java application. You may recall from the first app, we had to specify Android app, and there were some other options. Here, Eclipse has looked at it and said, well, you've only got one option. It has to be a Java application. So it knows this is not an Android application. So I'm going to click on Run Application. And we need to save it, because what we haven't done is saved it. The little asterisk to the left of the file name is telling us we haven't saved it. So I'm going to click on OK. And we can see down here, in the console area, which is sort of the output area, and I can double click that to bring that up to full screen if necessary. So it's telling us that the program terminated normally, and this is my test message. That was the output, which of course is the output that we put in here. It's a very simple little test there just to sort of see that things are working. Now, of course, that's not very useful because it's certainly it's displayed a message, but in reality, with an app or any type of program you're running, you normally need to do something. You need to store and manipulate information. And the way to store things, or what Java refers to those as, and many programming languages do the same thing, they call those variables. So what we want to do is we want to create a variable and we want to output that message. So in this line here, system.out.println, because we put what we wanted to print out, essentially Java internally created a slot, some storage, to allocate that so that when it came time to print the message, that it would print it out. So it's virtually used its own internal variable to do that. So why don't we just change the code now? We're going to specifically create our own variable and display that message. So I'll show you how to do that. Now, if we want to store something that is an alphanumeric number, an alphanumeric string, and that's something that's got both letters and numbers or different combinations, we use something in Java called a string. So we can type in string. We'll call it test message. I'm going to put equals. This is another test. And incidentally, whatever you're typing in Java, you've got to finish with a semicolon. A semicolon is the way to tell Java that's the end of this line and to move on to the next one. There are a few exceptions, and a couple of quick ways to find, or a couple of quick exceptions are, firstly, if a line ends in a brace, either a left brace like that one or a right brace like that, generally speaking, you won't be using a semicolon. So you wouldn't need to put a semicolon there or up here, and the other exception is a comment. Because a comment is ignored anyway, whether we put a semicolon there or not isn't going to make any difference to the code. As far as it's concerned, that output is there purely for you to look at anyway. But in other situations, I'm going to press enter here just to make a bit of space, and likewise down here. And in case you're wondering, a quick navigation tip: Command and left arrow, or Command and right arrow goes to the start and the end of the line, and it's Control, left arrow, and right arrow on a PC. Now, if I make a bit of space there, and if I go back to the end of that line, and if I press delete and leave it there, that's now an invalid line. And you can see if we hover over it, it'll probably say the semicolon's missing. Insert the semicolon to complete the block statement. So keep in mind, if you're seeing an error like that, more than likely, that's the reason. Now, the other thing is, you'll see these warnings pop up. Now, these warnings aren't necessarily problems. Sometimes they can just be a suggestion or just something for you to note. In this case, it's saying we've created or Eclipse, the environment that we're using to create our Java application, is saying, I've noticed you've created this variable in our variable called test message, which contains this message. And incidentally, by putting those double quotes around it, that's how we've told Java that there's a string effectively. And so what Eclipse is saying is the value of the local message test message is not used. So it knows that we haven't used it anywhere. So as soon as we use it, that message should disappear. So why don't we just change this, and we'll put some output on the next line. System.out.println. This time we want to use the variable. So I've typed in what's different to the previous line. The previous line, we had this string, and we got the computer to internally store that. In this case here, we've created our test message, and we're telling it to output our test message. Now, what you've noticed also is there's no warning, and that's because Eclipse has noticed, oh, okay, we are using that now. And just to confirm a comment, by the way, and show how a comment works, if we put a slash there in front of that and a space, that's changed to green. And now, as far as the system is concerned, we're not using that. It's purely there for us to help us understand the program a bit more. And consequently, as far as Java is concerned, we're now not using that variable. So just keep in mind, whenever you see two slashes, that means a comment. Okay, so I'm going to put that back, and the warning message disappears. I'm going to save it. Anytime you want to, you can go up to File, Save, or you can do Command S on a Mac, which I've got obviously, or Control S on a PC. So I'm going to save that. I'm going to click it. And now that we've done that Run As command the first time, we should just be able to go up here, so long as we've got our Java code that we want to execute selected, which I have, I should be able to just click on that. Then down the bottom of the screen, and again I'll open it up, we've got this is my test message appearing first, and this is another test appearing second. So you can see that the way Java works is it goes down sequentially, line by line processing. So it found this line first, it outputted that line, then it moved on to the next line and outputted that line. So you can see the difference now that we've got a variable here, and we've just outputted it. And by using that variable name, that's told Java to look into that spot and to find what was in there and to print that out. Now, in terms of naming of fields, it is case sensitive, so we can't put test message because as far as Java is concerned, that does not exist. Test message cannot be resolved to a variable, and that's because it's test capital M. So we have to be specific. So if you've got an error, make sure you check your case very carefully to make sure you're using upper and lower case. Now, in terms of standards, what Java do recommend is you have to always start a variable name in a lowercase letter, and if there's more than one word, the subsequent word should be capitalized. The first letter of those words should be capitalized, and that's called camel case, and that's really just a standard definition or a standard way to name your variables. And it gets by doing it that way, it makes your applications easier for other people to maintain. And also when you're looking at other people's code, if they do the same, it makes it easier for you. And just in terms of naming, do make sure you take the time to name your variables properly. You can see that in this case, I've called it test message. So that gives us some indication as to what it was. Now, Java would quite happily allow you to say something like, let's just say we'll call it Y. And change that to Y. And that will work quite happily. We can run that. Oops. Oh, so we'll save that first. I'm doing Command S and then run it. It'll still work, but you can probably agree that the string Y, the letter Y is probably far less or far harder to try and remember what this variable was created for. So it's far better to put some more information on what that variable was about, like so that it makes sense, particularly down the track, because while you might remember now when you're writing this program today, in a few days or a few weeks or a few months, you might forget completely why you called something like that. So by being specific, you've got a far greater likelihood of getting up to speed quicker and remembering why you did something in a particular way. Okay, let's move on. Next thing I want to talk about is talking about some numbers. Now here we've created a string, and we could put numbers and letters in there. So I could quite happily put 56. I can put a % sign, an @ sign, an exclamation mark. Quite happy to do that. I'll save that off, and if I run it, whatever's in there will be displayed. So the computer will quite happily accept whatever's in there. So what we can do is actually add two strings together. Okay, so I'm going to delete that. Let's have another string. My second message. Okay, and I've called my second message demo. So what we can do is put test message plus my second message. Now if I do that, can you guess what's going to happen? We'll save it and run it. This is another test demo. So Java has connected the contents of test message, which is this is a test, with my second message, which has got a space and the word demo, and it's outputted this is another test demo. So you can concatenate strings in that fashion. But let's look at numbers because they work in a similar way in terms of adding. So let's go through and do that. Now to allocate a variable that's a number, unlike the word string, we've got to tell Java what type it is. So we're going to start off and use an integer, which is a whole number. So let's do that by typing int. And we'll call the first one first number equals. Now we can't do this. You might think we can type 55 to make it a number, but that doesn't work like that, and it'll tell us that that's an error. We cannot convert from string to int. So anytime you wrap something in double quotes, Java thinks that that is a string. So if we want to define a number, we've got to delete that, remove the double quotes to make it a number like so. So we've now allocated the number 55 to first number. Now that's different to a string, which can be anything. I showed you just a few minutes ago how we could put exclamation marks or whatever we wanted in there. A number has to literally be a number. Because we've told Java that this is an integer is a whole number, we can't use a decimal point. So we can't type 45. Because it'll come up and say, cannot convert from a double, and that's another type of variable which we'll talk about. A double is a different type of number, which of course has got decimals. So you can see what Java is doing. Java is trying to come back and tell you when you've typed something obviously wrong. Now there are other computer languages out there that don't do that, and they leave you to define, to make sure that you've done the right thing. But Java will quite happily tell you that if you've said that this variable is going to be an integer, you have to make it an integer, and it will tell you and actually won't allow you to do anything else but an integer. So although you might think that's lacking a bit in flexibility initially, what it is a good thing. And the reason that it's a good thing in the end is because it's making your code less likely to have bugs, because those errors that might traditionally be associated with not putting numbers into the right spots or putting strings where numbers should be, they aren't even going to happen in the first place, because you can't get the program to work until you've done those basic things. So I'm going to delete the decimal points, and I'm going to type another one. Let's do another number, int, and we'll call this, unsurprisingly, second number equals 5. Again, semicolon on the end. So we've now got two numbers, and we could use the system.out.println, and incidentally, that will not work on Android apps. Just to be clear, this is purely for this learning Java exercise, but we'll talk more about that in future videos. So now we've got two variables. Let's add two numbers. That would be a common requirement if, for a lot of applications, to add two numbers. So we can type in int result equals first number plus second number. Okay, so we've got a result, and you notice by putting that line in, the warnings for first and second number have disappeared because, of course, they've been used, but now we've got a warning by result, because even though result has been defined, we haven't used it anywhere. So result will now contain, unsurprisingly, 55 plus 5, and we can do a system.out.println result. And the warning goes away. I'm going to save that, make sure that's selected, and run, and you can see it's 60. So this is the difference between using numbers and strings. If you remember when we did the string concatenation previously, this is another test demo. So it's added the contents of the strings together, but the number has been processed much like it would work in a calculator or in it's standard maths, in other words. It's added, it knows that, okay, if one's 55, one's 5, therefore the answer has to be 60. So we could then go put something in brackets, put the result. So it's integer result equals whatever the result is of adding those two numbers, and times that by 5. Now, can you guess what that would be? The answer should be 300, because it should be 55 plus 5 is 60 times 5 is 300. So I'm going to save that, and we'll run it. And sure enough, it's 300. Okay, one last thing now before we finish. We're going to talk very quickly about doubles. We saw that little double reference come up before when I was typing in a decimal point. There's the concept of doubles and floats in Java, which essentially allow you to store decimal numbers, and it's really the difference between the two is that how much precision you want in both of those numbers. So we're going to type double, my value equals whoops, we'll put something on the end. And we're going to do a system.out.println my value. Run that. 123.4.67894. We can type in another double. So you can see basically a double is just another type, but this one that accepts doesn't just require whole numbers. It uses decimal points as well. My second value, and we'll type in quite a few decimal points like so. Still quite accepted. Plus, and whoops, I made a typo there. Remember, the first letter of a variable should be lowercase, my, and we'll put plus my second value. Okay, let's save that and we'll run it. So you can see down here the number, it's quite a high amount of precision involved there. So it's quite happily stored all those decimal points. So as we'll move through this Java tutorial, we'll be going into more detail about different types of variables, but think of these things here. String, that's a type. Int is a type. Double is a type. And we'll be talking more about those as we go through, and you'll see this more in the course actually as we're creating our apps. But this is giving you a little bit of an overview of how variables work. In the next video, we're going to solidify that and move into the concept of classes. So I look forward to seeing you then.